This is Electrostatics Conceptual Notes number 41 through number 50. Every proton in the universe is surrounded by a couple different things. One of them is a gravitational field. So here's my proton. There would be a gravitational field that would be coming from the force of gravity. That's why you stay on the Earth, because you're full of protons. And it also has an electric field. So this electric field points out. And this is why you can conduct electricity, or why you can shock somebody. Same type of thing. For number 42, it says the direction of the electric field line shows the direction of the force on a test positive charge. So you'll notice here I've got a positive charge in a field with two positive charges, and that positive charge is getting pushed away from the positive charge. On the other diagram, you'll notice the positive charge here is going towards the negative charge. So it wouldn't matter really where I put this positive charge. This one would end up going this way. If I put the same positive charge in this field, it's either going to go to the right or it's going to go to the left and stick to the negative charges. So that's what those electric field lines really do. For number 43, says suppose a hollow metal sphere has a large negative charge on it. The electric field strength inside the sphere is 0. Notice the charges on the outside, so the field strength on the inside is 0. If all these lines are pointing towards the center, they all cancel out at the center. But in essence, anytime you see a metal sphere, all the charges love to be away from each other on the outside surface, so there's no charge on the inside surface. For number 44, suppose you touch a negatively charged object to a metal sphere so that the electrons move from that charged object onto the sphere. After the charged object is moved far away, electrons on the sphere will be distributed evenly on the sphere's surface. So if I have a sphere like this and I put a bunch of negative charges on it, so I get a rod that's negative and I touch to it and those negative charges move over to this one. At first they're on the side, and then when I move that other rod away, so when I move this rod infinitely far away, it doesn't have as many charges, all the charges on this sphere will be distributed evenly over the surface. For the next question, which is number 45, it says electrical potential energy is the energy a charged object has because of its location. And we know it's because of its location because of the equation. The electric potential energy is equal to Q, which is the charge, times E, which is the electric field, and then D is the distance. So that tells us our location. For number 46, a small positively charged object near a positively charged sphere is moved closer to the sphere. The energy of the small object increases. So we can draw this one also. If I have a positive object and I take a little positive piece and I move it closer to it, we know that when I get it to about here, the strength of repulsion is really big compared to what it would be right here. So I'm moving it, so it's moved in this direction. This is the force. If I get it closer, that electrical force will be bigger between the two, and they both push each other out with the same amount of force because of Newton's third law. For number 47, when an electron is brought near a negatively charged sphere, its potential energy increases. Why is that? It's because work was done to bring the charges together. And if we go back, we remember that work is equal to the change in energy. And typically we look at the change in potential energy. And so because the potential energy increases, then we know that work was done to bring those two charges together. For the next one, which is number 48, it says if two negative charges are held close together and then released, the charges will accelerate from each other. So we've heard about that one before too. For number 49, electric potential is defined as, so this is just a definition, it's the electric potential energy of a charge divided by the quantity of the charge. So here we've got the potential energy divided by the quantity of the charge, and if you remember, change of potential energy is work, so it's just work divided by the charge. Sometimes you'll see it that way, other times you'll see it this way, and so that would be just the electric potential. Then finally, number 50 says a volt is a unit of electric potential. So if we're looking for electric potential, we are looking for voltage, and that would be number 50.